Okay, looking at question 3. So again, we're dealing with a sample um, population within a normally distributed population. So we know that the distribution of football touchdown passes is normally distributed with an average of 250 feet, standard deviation of 50 feet. And then they looked at a random sample of 49 touchdowns, assuming that those are touchdown passes. And so they want to know, what is the probability that 49 touchdowns traveled an average of less than 245 feet? So we're going to figure out what the probability that a sample of 49 comes out less than 245 feet. So let's start by writing down some information here. So we know that, again, our average here is 250. We know that our standard deviation is 50 feet. And we know that the population, or the sample size that we have here, is 49. Okay, and so we want to know the probability that 49 passes are less than 245 feet. So we want to know P. P is less than or equal to 245. Okay, so that's what we're trying to find out. What we're going to do here is just going to look at a normal distribution. I'm going to do this on the calculator, and on the calculator I'm going to use the normal CDF. Okay, so the normal CDF function, and the way that this works on the TI-83 is it looks for these 4 parameters: the lower limit, the upper limit, the average, and then since we have a small sample size here, so we sampled 49 touchdowns, we're going to go ahead and normalize that sample. Okay. Now, so that's what we'll do here. And the way that we normalize that sample is we look at our standard deviation, and then we divide that by the square root of our population. So the square root of the sample size. So the square root of n. So those are the 4 values that we're going to put into that normal CDF function. Now there's probably, well, not probably, there are ways to do this on spreadsheets and using Excel, using Google Sheets and so forth. So I'm just going to do it on the calculator in this one. And so I have a TI-83 calculator, and so I have to know what to put in there. So to find that on there, let's go ahead and clear this. Okay, so on the TI-83, I'm going to go to second distribution, and I'm going to do a normal CDF, and I'm going to put in my 4 values. So I'm doing a lower, I'm looking for an upper limit on this. And so again, if I look at my kind of normal distribution here, right? So here's my average is 250. I want to look at the number of passes or the percent of passes, the probability that my passes would be down here at 245, right, or below. So I'm looking for the probability. I'm looking for this area underneath that curve there. So my lower limit on this is actually negative infinity. Okay, so my lower limit is negative infinity. My upper limit is 245. That's where I want to stop. My average here, I know, is 250. And then my standard deviation is 50. And then the square root of 49 is 7. So those are the numbers that I'm going to to put in there. Now, to put in negative infinity, there's not a negative infinity like button on the calculator. So the way that we're going to do this, we're just going to put in a really, really small number. So I'm going to put in -1 times 10 to the 99th. And so that's -1 with 99 zeros after it. So that's a really, really small number, and the calculator will interpret that as a negative infinity. So to put that in, I'm going to use the negative key down here. So negative, right, -1, and then to do scientific notation, I'm going to go second, and then comma right here. So that EE. Okay, so that's times 10 to the 99th. Okay, so it's -1 times 10 to the 99th. So that's my lower limit, and then the comma. So the comma key is right here. And then my upper limit is 245. My average is 250. And then I'm going to put in that normalized sample size, right? So again, to normalize that, I do this standard deviation divided by the square root of the population. That's going to be 50 over 7. So I'm going to put that in parentheses. So it's 50 divided by 7. Okay. And then another close parenthesis to close off that normal CDF. And so if I enter that, I get 0.2419. So I get a P is going to be 0.2419, which is 24% approximately. Okay, so the probability of 49 passes being less than 245 feet is approximately 24%. Okay, go ahead and end that problem here.